Let's explore the fascinating world of sine and cosine, the fundamental trigonometric functions. Sine and cosine are fundamental functions that describe relationships in the unit circle, forming the basis of trigonometry. Let's start by understanding what sine and cosine actually represent. Sine and cosine are ratios that relate the sides of a right triangle to its angles. Sine of theta equals the opposite side divided by the hypotenuse. Cosine of theta equals the adjacent side divided by the hypotenuse. In this right triangle, we can see the opposite side, adjacent side, and hypotenuse that define our sine and cosine ratios. The unit circle provides a powerful way to visualize sine and cosine. The unit circle is a circle with radius equal to 1, centered at the origin. On the unit circle, any point can be expressed as cosine theta comma sine theta, where theta is the angle from the positive x-axis. The coordinates of any point on the unit circle are given by cosine theta and sine theta. Let's look at some important angles and their sine and cosine values. There are several common angles whose sine and cosine values you should know. At 0 degrees, sine equals 0 and cosine equals 1. At 30 degrees, sine equals 1/2, and cosine equals square root of 3 over 2. At 45 degrees, both sine and cosine equal square root of 2 over 2. At 60 degrees, sine equals square root of 3 over 2, and cosine equals 1/2. At 90 degrees, sine equals 1, and cosine equals 0. Here are the key angles marked on the unit circle, showing their positions at 0, 30, 45, 60, and 90 degrees. Let's visualize how sine and cosine behave as functions. The sine function creates a smooth wave that oscillates between -1 and +1. The cosine function looks similar, but starts at 1 when x equals 0. Both sine and cosine are periodic functions that repeat every 2 pi radians or 360 degrees. Let's explore some key properties of sine and cosine. The Pythagorean identity states that sine squared theta plus cosine squared theta always equals 1. Sine is an odd function, meaning sine of negative theta equals negative sine theta. Cosine is an even function, meaning cosine of negative theta equals cosine theta. Sine and cosine are related by a phase shift of 90 degrees. Sine and cosine appear everywhere in science and engineering. Waves of all types, from sound to light to ocean waves, can be described using sine and cosine functions. In music and sound engineering, sine waves form the building blocks of all sounds we hear. In physics, sine and cosine describe circular motion, pendulums, and oscillating systems. Engineers use these functions extensively in signal processing, electrical circuits, and mechanical systems. Let's recap what we've learned about sine and cosine. Sine and cosine are fundamental ratios that relate angles to side lengths in right triangles. On the unit circle, they give us the x and y coordinates of any point. As functions, they create smooth periodic waves that repeat every 2 pi radians. They're connected by the Pythagorean identity, where their squares always sum to 1. These remarkable functions appear everywhere in nature and form the foundation of countless technologies we use every day.